So, shall we pray? Our Father in heaven, I want to say thank you for this wonderful time you've given us. As Lord will be starting our lesson, may you start with us and may you end with us. Help us not to understand and help us to ask questions that we do not understand, and help us to continue doing our work. May you continue blessing us, Lord. May you bless those who will be coming to join us, who are still coming, and may you bless each and every individual is here. In the name of Jesus Christ, I pray to you, Lord. Amen. So, before we go any further, can anyone give us a summary of what we did? What is a fraction rationale? When you talk about fraction rationale, what is it? Someone to give us a rappel of what we did.
Fraction rationale is a polynomial in fraction form.
In fraction form, okay. Yeah, and then when it comes to decomposition, how do we decompose it, both in C and in R? How do you know that now we can decompose? Yeah. What factors or how can we decompose a fraction rationale? Thank you for the one who answered the first question. Anyone else to come in? When it comes to decomposition, what key factors do we, or someone to tell us how can we decompose? Before we start decomposing, before we write its form, what's the first step that we do? What we do to a fraction rationale? What do you check for first of all before you do anything as you are planning to decompose it? Yeah, the one wants to come in.
The degree of.
Sorry, can you?
That the degree of A is less than the degree of B.
And then what does it mean when the degree of A is less than the degree of B? You may continue. What does it mean? I'm sure.
We want to divide median, we'll go straight into decomposition.
Okay, that's very good. So it means the party on tier is equals to 0. Yeah, you guys, you are following. Yeah, you are following. So we shall continue from here. So there's you'll find that when you are decomposing, you find the value of B to have a bigger multiplicity. Maybe it has a multiplicity of 3, it has a multiplicity of 4 or 4. So there's this principle that we use so that we can find the value of each part of a determinant which has a multiplicity of 4. So this is what we call détermination de la partie principale relative à un point. So this is what we'll be looking at. How can we determine the partie principale? So first of all, let us identify what does it mean. So for us to determine it, we do division suivant les puissances croissantes. So we're going to do division of puissance croissant. So our powers will be increasing. For the other division that we do in the normal one, we do for the puissance décroissante. We start with the highest power, it will be dropping like this, a polynomial. But for us to determine the partie principale, we'll have to do a division, Euclidean of puissance croissant, where you start with a power 0, power 1, power 2, it will be going like this. So this is what they're saying, soit A, B, des polynômes de k dx avec b0 is not equals to 0. So our b, we're talking about the dominant when we put 0 is not equals to 0. Et soit m appartient.
Can I kindly repeat on the sorry. Kindly repeat on the proposition. I didn't really get it.
Okay. So first of all, we're looking at détermination de la partie principale relative à un pont. So we use this specifically when we've got a part of B, which is our determinant, has got in a Racine form of degree, in a Racine form of multiplicity, maybe 3, 4, is very big. So how can you find its values when you have put its form? Is from the decomposition. How are you going to find if we've got it? I'll give an example of got it. One, we've got this. We have here we've got 1 over, maybe here we've got x minus 1. We do this, right? Puissance multiplicité 4. This is its multiplicity. So how are we going to write it? In the form of it, it will be what? It will be its form, the decomposition. How are we going to write it? Someone to help us? What will be its form? Because we have already identified that its degree is less than what, right? We'll go direct, right? How are we going to write it? Its form, the decomposition in R. How are we going to write it? S'il vous plaît, someone to help us. Benzo, how are we going to do this? Benzo, can you help us?
And this supposed to factorize the denominators.
To factorize, no.
As in
It's already in first of all, you have to identify if the denominator is in its simpler form. Is it in its simpler form, da R? The one who said that, is it in its simpler form, da R?
in R, it's supposed to be x plus 1, x minus 1, then x squared minus 1.
X what?
Squared.
He said X.
Open brackets x plus 1 close, then open x minus 1 close, then open x squared minus 1 close.
This is not the difference of two squares. The difference of two squares is when it's inside here, I've got squared here. This is the multiplicity. It's different. This is a multiplicity.
All right.
Yes. So what you're saying is somehow correct, but you are using it in a wrong way. You know what we're supposed to do here. Just tell me. Just say what you think. Anyone else?
It is already in R.
Why? Because
the coefficient, the x, it is already in its simplest form. It doesn't have any power to say. It is just 1.
Okay. What of this? What of this?
Which one?
X squared plus X plus 1. Is it irreducible da R? I gave you this question. Is it irreducible da R? And if it is, what is the reason? And if it is not, what is the reason? The one who gave us this, is this irreducible da R? And why? If it is not, then why? This is very important.
That one in R, it can be reduced.
Reduce it. It can be reduced in R. What are you going to have?
No, it can be reduced in C.
In R, is it reduced?
No.
It is not reduced. In C, is it reduced? First of all, before we even go to C, why is it not reduced to its simpler form?
Because the coefficient of the variable with the highest power is 1.
The coefficient. No, that's not correct. The coefficient is no.
Can I try?
That's yeah.
Is it because when you try to find the discriminant to give a negative, that's why it's irreducible? Something.
Yeah, and then for this one, is it irreducible da R? The one who answered. This one here.
I think so. I'm not so sure.
Why do you say you are supposed to be sure? For you to answer this, then you can answer this.
Okay.
This is a multiplicity, mind you guys.
Mm-hmm.
This is a multiplicity. What we said when we are simplifying it is simpler form. We said it's the same polynomial, so the degree of a polynomial must not change. This is why we put its degree to be, because when you display it inside here, it will go back to its normal form. You've seen, huh? But here I've written it in its simpler form. The reason why this in R, I gave you this question. This in R, why, when I said, is it irreducible? The answer is yes, it's already reduced in R because this discriminant is less than 0. And in R, we said a polynomial is only irreducible or reduced to simpler form when it has of degree 1, which is here degree 1. Here I've got the degree of this polynomial inside is equals to 1. This is the multiplicity outside. You don't use this as your degree. You use the degree of this equation, the racine. Its degree is 1. So in R, this is already decomposed. So you go direct to fractional Rationelle decomposition. In R also, this is already what decomposed because its discriminant is less than 0. And the conditions in R are that a polynomial will only be decomposed in R when it has what? When it has a degree of 2, and this discriminant must be less than 0. And when it has a degree of what? When it has a degree of 1, then it's decomposed in R. In C, it's only when it has a degree of 1. So that's why in C we put this, we take this, we put it in its identical. In C, the identical nancan of this is x minus j, x minus j bar of this. Yeah, so that's it about this. So here, someone to tell us what will be the form after we have identified that we'll go, because someone told us that we'll go direct now. We're going to go direct to our, decomposition. We're going to write its form. We've already discovered that here, We've already discovered that here the party on here is equals to 0, so we're going direct. Tell me the form. What would be the form of decomposition in R? What would be the form? Simon Nyendwa. Simon Nyendwa. What would be the form?
For the form, I think we will start with power 4, then start reducing with 3, then 2, then 1.
So are we going to be adding? Are we going to be subtracting? Are we going to be multiplying? Because the way you say, so I'll be following you. You tell me, how is it going to be so that I can be writing here? You are okay? You're okay? Simon, we can start. I'm waiting for you. Are you still connected?
I think we are going to be multiplying.
Multiplying, okay. Then if we be multiplying, then no, we're not going to be multiplying. Guys, I'm sure you remember the form, the format. I'm sure you remember the Jabez. Jabez, you are here. Jabez, what are we going to do here? Jabez, I'm sure you can get me.
Just a minute.
Okay. Mulenga Chewe. What are we going to do here? Mulenga.
Trying to figure it out.
Okay. Samantha.
I'm trying to figure.
Okay. Everyone is trying to figure it out. Teddy. Teddy, you're here. Teddy. How are we going to do this?
We are expressing it in R or in C?
In R. In R. Just in R, this. Okay, I also trying to do some. David Morena.
Same. I'm trying to figure it out.
Okay. Everyone is trying to. You guys, the holiday which you had, is it the day for yesterday or this long holiday? You never pass through the notes. Chris, what do you think, Chris? Mukwa. Anyone who has found?
What's the question?
The question is, what will be the form of decomposition that are here?
For which one?
For this one here.
Can I try?
Yes, I'm sure you found it. I'll even be writing now.
Okay, so knowing that the racine is positive 1 of order 4, we're going to say 1 over x minus 1, everything to the power 4. And using what Simon said, we'll say 1 over x minus 1.
X
minus 1 to the power 4. Then, is it plus? Then we'll say plus 1 over x minus 1 to the power 3.
So before we even go further, before I continue, where is the one coming from? Here again to be power 4. We're
No, it
adding,
will be
right?
power 3.
It will be power 3, right?
Yes.
Okay, that's very good. That's very good.
Then 1 over 1 minus 1 to the power 2.
Here 3, eh?
Yes, there are 3.
Then 1 also, eh?
Yes.
Okay.
1 over x minus 1 to the power 2.
Minus 1.
Then plus 1 over x minus 1 to the power 1.
1 over, you understand, that's 1 on top there.
Yes. That's
Minus A.
I think.
That's all?
Yes. Yeah.
Thank you very much for that. Who gave us this answer?
Changu.
Okay, thank you very much, Changu.
You're welcome.
Okay, fine. So, Changu, before you even go, I've got a question. I have a question. I didn't understand. I just want you to explain to me. Where are we getting this one? And have we decomposed it? Like, I don't know where this is coming from. Have we decomposed it? So this is what they say when they say you're decomposing in R. It's just this. Then you're done. And where is the one? Or the one is the same here, one, right?
Yes.
It's the same one.
It's the numerator. Oh,
Okay.
yeah. Yes.
Okay. And okay. So we have decomposed it.
Yes.
Okay. It's straightforward then. Anyone else to help us?
I wanted to ask, is the involvement of CX plus as in to find the solutions of CX plus CX plus D. Are we also supposed to find those things as we are decomposing?
Yes, we have to find them, but you don't just introduce it. What's the C? What's the X? What's the D? Why are you introducing them? We have to introduce them here also.
No, okay. It was just a query.
Okay. Okay. So are we all okay with what Chango has given us? If we're all okay, we can raise our hands. Are we all okay? If we're all okay, we can raise our hands. Then if we're not all okay, there's someone with another who is saying no, it's not this. Anyone else? Thank you very much, Chango, for that. Thank you very much. You guys, you've not passed through your notes. Here we're just writing its form. Its form, we write it. Chang was just okay, but where the one came from, that's where I was a bit worried. So here we'll name this to be lambda 4. This is its form. We have to find these. The lambda 4 here are going to have lambda 3. lambda 3 with our x minus here, forgive me, lambda minus here 3, then here to be here to be this is its form lambda 2 not lambda alpha 1. Now we have to find this value, this value, this value, this value. You don't get this and put it on top. No. After you've proved, so you have to go back to the steps. After I've said its part on and here is equals to 0, we go directly to its division, its decomposition. Its form it will be with the highest power to be dropping. So it will be lambda 4 over x minus 1 to the power 4 lambda. So we have to identify what is our lambda. 4, what is our lambda, 2, what is our lambda. Then after we find their values. That's why we're going to put them here. It's not that here is automatic 1, 1, 1. The idea was very okay. Chango, yeah. So guys, this we should keep in mind. This is the form in R. And you should check and see how we write it. And then the one we talked about, the C and the B, the CX plus the B. Or would have introduced it if our denominator had x squared plus x plus 1, because we use it for the one with the degree 2, the R. That's when we introduce this. The form of x, c times x plus c, d. It's a polynomial of degree 1 because it has of degree 2, so it will start from degree 1. This it has of degree 1, so it will start from degree 0. That's why we take this to be a constant. This constant. So that's what we're supposed to do here. So this is what I was saying, that if we go to the power 4 like this, they'll tell you find this, find this, find this, find this. How can you find it? So for you to find it, this is why you use now theorem de Partie Principale. It's going to make your work easier. You are going to find both of them, or the four of them. You're going to find them at the same time using division suivante les puissances croissantes. So this is what we'll be looking at as we continue using this formula. So keep in mind of this. Yeah, so this is what I wanted to explain. Thank you very much. So I'm saying soit A, B, des polynômes, soit que de x avec 0 is not equal to 0. So our denominator must not be equal to 0, A, soit M appartient à, and this M is standing for our order, our multiplicity. M is given here. They will tell us M est donné. M donné. So, alors, il existe un couple unique. So there will be a unique couple which will come up. We're going to have Q and R, which you know that is our coefficient and our remainder. When you do the division of this, the division you're going to have your Q and your remainder. The polynomial the kx. Verify our R is equal when we divide this into this. Our R, because this is dividing this. Our R will be equals to B for Q, which will be our quotient, plus xm plus 1 for R avec degree de Q less than M. So this is what we're going to have. We're going to understand it more when we do the example. So this is what we're going to do here. On dit qu'on a effectué la division suivante, les puissances croissantes de A par B à l'ordre. So we said it's a division Euclidean of les puissances croissantes. What do you mean when you talk about this? example, we've got I is equals to this. We've got B is equals to this. B is written in Poisson's croissant. Croissant de croissant. What does it mean when you say croissant? A sweet is croissant. A sweet is the croissant, eh?
Increasing.
It's increasing. The croissant is, is decreasing, right?
Yeah.
Yeah, so when you say a polynomial of a Poisson's croissant, it means its non-can is increasing. So this is croissant. This is decroissant because the powers are doing what? Are reducing. This is decroissant. What the one which we've been doing in the normal one, it was the Poisson's decroissant, if you check very well. But for us to use the partie principale, we have to do what? To divide these two with its Poisson's croissant, the Poisson's croissant. So we're going to do, first of all, we said B0 is not equals to 0, right? Because when you put our 0, it will be this. So effectuer la division euclidienne suivante la Poisson's croissant de A par B. So we're dividing this à l'ordre 3. So we're going to stop at order 3. When our coefficient reaches on 3, we're going to stop. When our coefficient reaches on this, we're going to stop. That's what they mean. So we've put this in la Poisson's croissant. We've put this our R in Poisson's croissant, and then we do our division Euclidean. This into this, we do everything until we reach on order 3. That's when we're going to stop. So until our coefficient reaches on order 3. So we've reached on order 3 here. We'll do what? We stop, and then we get these values here. We get this, their coefficient are the ones we're going to replace in what were written here when we're doing it. What were written for our R, B, for our alpha 4. So our alpha 4 be equals to 5. The other one will be equals to the other one. So it will be equals to 5. It will be equals to negative 5. It will be equals to negative 3. The alpha 2, the alpha 3, it will be equals to the alpha 2 because to 2 until you go down. So this is the division that you have to know. And now after you found that, you use for the coefficient. Then you come here, détermination de la partie principale de f. Soit f is equals to a over b appartient à fkx avec degré de a less than degré de b. Soit a appartient à k, un polynôme d'ordre m. So this is what we are doing. First of all, soit a appartient à k, this is its pole. A is the racine, belongs to k, un pole d'ordre m. So a pole has got an order appartient à n3 de f. C'est-à-dire b is equals to x fois a m, x moins a d'ordre m fois c. C is our polynomial which will be dividing a. It's the polynomial c, not this polynomial. You are going to, as we go down, you are going to see what I mean. So we've got this here. So what are we going to do? This is the step. So on our f is equals to a x minus a m c. So c is another polynomial. We are finding for this, mind you, be careful. We are finding, we're using a partie principale for this racine here for x minus a. A is our racine of multiplicity m. And then our c is any other non-can which we're going to have this side. This stands for any polynomial which we have. So we have étape 1, there are steps. On fait un changement déterminé. So on pause. We pause first the racine, which is inside. We say y is equals to x minus a. Then our x will be y plus a. We'll go back to our equation. We say f r y. Where there's x, we're going to replace with our y. We want to have a polynomial of a fraction Rationelle of a variable y. So we're going to put our y, so it will be y plus r. Where there's x, we're going to put y plus r. So ar, y, and then here, or this whole thing is standing for y. Since we said x minus r is equals to y. So this whole thing here will be equals to y to the multiplicity m. This is why we have y multiplicity m. Our C1, we're going to put y inside, and then we're going to distribute it. And then we're just going to divide this ARY with, when we put the variables of y, with our C1 y. This is what we are telling you. Avec C1, 0 is not equals to 0. This is what we said here. I said B0 is not supposed to be equals to 0. That's what we had said. So when we're done with this step, we go to étape D. On effectuer la division suivante les puissances croissantes. What we did here, after we've come up with that, we're going to do now the division of the puissance croissant. The this is what I'm saying, is a division ingredient. We're going to do a division of RRY with our C1Y. This of the racine which we are finding, we're not going to do any division ingredient of it. That's why it's just represented by Y, M. Be very careful there. So we are doing a division of this by this. Our order will be what? Will be A minus 1. Our order will be, we're only going to stop at M minus 1 because this would have order 1 here. So it's M minus 1, which will be our order. This equation, you need to know it, where you are going to, that's why here we had the 3. So we had the M minus something which gave us the order 3. So for us to find this order, we are going to stop is M minus 1. The M is for what? The M I said is this M minus the coefficient, the degree, the multiplicity which you're going to have here, and the multiplicity which you're going to have is going to be 1. It's going to be 1 most of the times. So we've got this is the division now. R1y is equals to C. We're using now this equation. This equation is the one we're using. So if we're dividing this into this, we're going to have this equation, this dividing into this for this part. This whole part is a polynomial, which is our Q, plus this whole part with our remainder. This is our equation of this. This is the equation which we're going to have when we do this into this, which is this. Donc, le partie principale is this whole part here. This is where I said the partie principale, which we are finding, is this lambda m minus 1. What are written lambda 4, lambda 3, and even down here, our y m will be reducing. Our y m is x minus 1, which is just its equation de racine. And then since we said the y is equals to x minus 1 minus a, we just come and replace it now here. This will be its form. Then what you find in division, which will be your quotient, you're just going to replace them here, here, here. That's all about partie principale. Partie principale. Are we okay? We do the example. You understand it more in the example. Can we move on? Is everyone okay?
Kindly just briefly repeat the explanation so that as we are doing the examples, I think we'll easily follow through.
Okay. What I'll do is we'll go to the example and then I'll be referring to the notes as we solve. We refer to the notes that this is what we meant here, so that you understand it more. Is it okay? It's fine. So,
yes, it's okay.
Okay. Décomposer en éléments simples sous fr de x. So we've got this polynomial f3. F3 is equals to x squared plus 1 over x minus 1 order 4 x3 plus 1. Is the down part is B, this our B. First of all, before we even do that, can we decompose directement here? Can we decompose? What's the degree of this fraction? What's the degree? What's the degree of this? Of our denominator? Changu. What's the degree?
I'm not so sure, but is it going to be 5? No.
5.
I'm not so sure. Like, since if you say x there, okay, no mind, I'm not sure.
No, say what you want to say, and then we'll agree in the group if it's true or if it's not true. Say what?
Okay, so I was thinking we get the denominator b. We say since there's x to the power 3 there, we say plus x to the power 4, the highest powers. That will give us 7. Then we say minus the power 2, so which means we'll have 5. That's what I thought.
So it will be 7 minus 2.
Yes.
What's the formula for finding the degree of a fraction Rationelle?
Wait. No, is it going to be degree A minus degree B? So which means it's going to be negative 5.
Negative 5. What does it mean when your degree is negative? When you find that when you do the subtraction, your degree is negative, what does it mean?
It's
you
null.
know it. What does it mean in a simpler way? How can you, when it's null, what does it mean? The party,
I don't know how I can construct it.
the party entière is equals to what? It's equals to 0, because when this cannot divide this, we used to say it we used to say it can't. It can't. This divided into this, it can't. It will be 0 to something. This dividing this, it can't, because the degree here is greater than the degree here. Allow our party entière will be equals to 0. Then this means that we can decompose it directement. There's no need of you doing the division Euclidean for you to find your party entière, because if your party entière is not equal to 0, you have to identify the party entière. When you identify it now, then you are going now to decompose now for the remainder over this also. Now the remainder you are going to find, you're going to, because the degree of a remainder will be less than this. That's what you're going to do now. That's what you're going to decompose. So you are correct, Changu. Thank you very much for that. So we go, so we're decomposing it in R. So degree de F3 is equals to 2. We said it's degree de R minus degree de B, which is 2 minus 7, which will be negative 5, which is less than 0. This implies the partie entière de R3 est null. What does it mean? It means this cannot divide this, and its party on its coefficient, which we call the party entière, is equals to 0. And then they pose the F3 d'A. So first of all, is this decomposed, all of it? Mulenga, is it decomposed in R? This, is it decomposed
Which
in
one?
R? This, the denominator here, is it decomposed in R? I'll start with this. Mulenga, is it decomposed in R? This. Just this.
No.
It's not decomposed. Why? Lillian, what do you think? Lillian, is this whole thing decomposed? Mwana Kasale, what do you think? Mwana Kasale, what do you think about this? Is this decomposed? Is this decomposed in R, this whole thing? Okay, let me just say, is this decomposed and is this decomposed? Mwana Kasale is not here. Samantha, is this decomposed? Are you getting me? Maybe you're not getting me. Jabez, yeah. Jabez can go ahead. Please, can you help us?
Okay, so I think it's not decomposed because that one, x minus 1 to the power 4, that one is decomposed because x at the degree of 1. But this one, it does the degree of 3, meaning that it's not decomposed.
How are we going? I gave you the identity of this in R. What's the identity of this?
Okay,
What's
so
the decomposition? What's the decomposition of this?
Yeah, x to the power 3 plus 1. It
I
will be
gave you in complex numbers.
X plus 1. Open bracket x plus 1 close, then open bracket x squared minus x plus 1 close.
Okay. Yeah, that's it. So there are two. If you remember very well, there's x squared, x to the power 3 minus 1. You also need to know its identity. That's why I said identities. If you just know the identity, you not give yourself headache of trying to decompose this. You just come and replace here. If it was x power 3 minus 1, what would we have? Someone else? If it was x minus 1, x to the power 3 minus 1. Changu.
It's going to be x minus 1 in brackets and x squared plus x plus 1 in brackets.
Very good. So when it's minus, you should know the one for x squared is supposed to be plus x. When it's x 3 minus 1. First you start with the way Changwa said, x minus 1. Then you do x squared plus x plus 1. When it's plus here, just know that when you start x squared, it will be minus x plus 1. Very good. Very good. So first we do our pause here. We've got T. So this is where our pause came from. They came from this. We said we've got R is equals to 1, which is this. This is our racine here, 1. D'ordre 4 of order 4. We've got a negative 1, which is of this. So we've got 2 here of no racine because it's not in a racine form. We've got R is equals to negative 1 d'ordre A. Alors on a B. So you have to check first, is your B decomposed in R before you do your fraction, the decomposition of a fraction. So our B goes to x minus 1. This x to the power 3 plus 1 is equals to, I've decomposed it, and this, the degree of this is less than 0. So my B is fully decomposed in what? In R. Alors maintenant, je peux faire quoi? Je peux décomposer ça. Alors on a F3 égale x squared plus 1 over this whole thing here. And then la forme da fx, this is the form de decomposition. Since there's no party entière, what we're going to do, we're going now to put its form. This form is very important. That's why that time I'd asked you, what's the form in R? What's the form in what? In C. You have to know, after you do all this, you have to know its form now. This is this form. F3 will be equals to lambda 4 over x minus 1 puissance 4 plus lambda this x minus 1 puissance 3, this over this. The powers will be dropping here as they'll be dropping here. So which one is our party principal? Which one can we use the theorem, the party principal? Then we've got beta is equals to x, beta over x plus 1. Then here we have ax plus b over x squared minus x plus 1. So this one, it has of a degree 2 and its polynomial. What we're going to find is supposed to be written. This is different from this, which has degree 1, which is just written in this form. So these, we've got these that we're supposed to find. These are the reals that were, these are reals that we're supposed to find. So we got the directement. Which one can we find easily here? This one we can find it easy, right? Jabez, Lawrence, you've been quiet. Lawrence, are you there? Lawrence, you've been quiet. What are we going to do here? We can, because first we identify which one can be easier to work with. This, which only has order 1. We can work out with this because when we multiply this everywhere, all these will be zeros, 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 zeros. All these will be zeros. This is what we have here. So I said my beta is equals to this for F2 is this part, which is also equated to this. So I multiply this with this part and this part. When I multiply this with this part, it's going to cancel with this part here. It's going to cancel. And then when I multiply it this other side, this will be 0, this will be 0, this will be 0, this will be 0, this will be 0. And then here when I multiply it, it will cancel. I'll have the beta. This is the beta which I have. So beta will just be equated to this part here with this being eliminated because it's going to cancel. So this is what we had here. So we know that our pole here is equals to -1. So where for us to have 0 here, we have to put -1. So x is equals to -1. So we're going to say our beta, because all these are 0, 0, 0, 0, 0, and we've got our beta, which will be equated to what? To F2. F2 is just this and this. Then we're just going to put now a -1 here, our -1 here, and -1 here. So when you put our negative, first on top, our -1 here to be 1 plus 1, which is 2. Here down, it will be 16. Here down, it will be 3. So when you multiply the 2, they're going to give you what? This will be 48, 2, so 48. So 2 into 48 is going to give us 1 over 24. This is our beta. So first you identify which one you can find first. So this you can find it because it's just itself. So when you just multiply it, it will cancel itself on here, on the final one here. So we found our this, which is equals to this. Now we've got this. Here it is to the puissance 4. So we can use party principal of this because these are many. Like, yeah, there are many. So if you use party principal, we can find this at one time, this, and yeah, these we can find them at once. We're going to find this when we find this because it will be easy. After we find this, the 4 of them, and we've already found this, we can find this now. There's a formula on how we can find this easily when you found all these. So you go now, détermination de la part. This is supposed to be partie principale de F3 relative on pole A is equals to what? To 1. So on this pole, this is the pole that we're doing, right? Yeah. So the first part, what did we say? The first step. Étape A, we said on pose y is equals to x minus 1. This is what we said here. What did we say here? when we're pausing, what did you say? The pause, we said, first of all, we said the y is equals to x minus r, which is the one which you are using, x minus r. The one which you are finding as its party principal, you are finding for x minus 1 order 4. So it's the one which you are going to equate it to y. Are we okay here? We're saying, so we're going to say, well, étape 1 on pause, that's étape 1 we said y is equals to x minus 1. And then we make x the subject of formula, x is equals to y plus 1. This is what we did here in our notes. This is what we did in our notes. Étape 1, we said first we pause y is equals to x minus 1. This is from what you are finding, the one that you are determining its party principal, which is this. So we're going to equate the racine inside d to y. Then you're going to make x a subject of formula, x equals to y plus a. This is what we're doing here. Are we okay with étape A? Is it making sense? This is what we did in étape A, and then we'll continue. I don't know if there's someone with a question. Yes, the mic is on.
Yes.
What
Could you repeat on étape 1, especially there where it was canceling each other and giving 0? I remained like a bit behind.
Did you the last non-cam you are there, right? The last, or if you're not there, but you've watched the video, right? On how we work out with this method. Hello? The one of
not sure. Not sure. But
were you there? Or have you watched the video? Someone to explain to us. Why is it equals to 0? Jabez, you are talking about pause. So here, what I mean is that when you multiply this whole thing, you are multiplying this to f². What is your f²? Your f² is equals to this part, which is also f² is equals to this. So you're going to put this here, which is equated to this. We are multiplying x plus 1. When you multiply it throughout, it's going to be x squared plus 1 multiplied by x plus 1 here. X plus 1 is equal to the x plus 1, which is here. They are going to cancel each other. This is going to cancel here. This is what I mean. When you multiply it to the other side, x plus 1 is not going to cancel with this. X plus 1 is not going to cancel with this. X plus 1 is not going to cancel with this. X plus 1 is not going to cancel with this. X plus 1 is going to cancel with this. So we just have the beta here. X plus 1 is not going to cancel with this. So we said our x is equals to -1. So here, if we've got x plus 1, when we put our -1 here at x plus 1, it's going to have -1 plus 1. It's going to be 0. It will make this whole thing 0. Here it's the same. It's going to be -1 plus 1. It's going to make this whole thing 0. Here it's the same. We're going to have -1 plus 1. It's going to make this whole thing 0. Here this whole thing 0. Here there's our x plus 1 already went. So it was cancelled. So here already have our beta. When we put it here, we're going to have x minus 1 minus 1, which is going to give us 0. So this will make this 0, this 0, this 0, this 0, this 0. What do we have? We've got beta is equated to x plus 1 over x minus 1 puissance 4 fois x squared minus x plus 1, because this has already cancelled. So now we come and put the -1 here, -1 here, -1 here, -1 here, here it's cancelled. So I'm not going to do anything here. -1 here, -1, -1. So -1 minus 1 to be -2. -2 to the power 4 is 16. Here to be 1 minus 1. Here to be 1 plus 1 plus 1 to be 3. This is a 3. This is how you will find your beta. This formula is just simple and direct. And for you not to confuse yourself, what I avoid, since you already know that when you multiply it here, it will give you 0, 0. You just know in your head that this will be 0, this will be 0, because when you put your x plus 1 here, it will not cancel with this down here. And when you come and replace with the -1, it will be 0 here because it's a racine. This is this racine. So when you put the -1 here, it's going to cancel. It will be 0 here, to be 0 here, to be 0. So not to make your work to confuse, to write a lot of things on the paper. You just know that this whole thing will be 0. So you just equate this whole part here to be equals to beta. This is why I just equated this whole part here to be equated to beta. My concentration is just on this part. And on this part, I know that this is going to, the one of the similar form is going to cancel because I've got x plus 1, which I've multiplied, which will be on top. It's just going to cancel. So I'm going to say beta is equals to this for this. Or where is a fraction of this over this for this. Simple as that. This we explained in the earlier, in the core earlier. Is it okay, the one who asked the question?
It's okay.
Okay. Thank you very much. Jabez, what did you mean? What do you mean by pause? What is a pause? It's like it's a racine. What do you mean, Jabez? I saw your question.
No, I mean the meaning of a po, yeah.
A
So it's
po, we
okay.
said it's just the same as a racine, right?
Oh, thank you.
Yeah. So we go etap on pause. Y is equals to x minus 1, which we said, which were earlier in our etap this is what we mean. We pause y is equals to x minus 1. Where is our x minus 1 coming from? We say it is coming from this. The one that you are finding the party on here. You get this racine, you equate it to y, and then you make x the subject to the formula, so that you can come and replace it the way we did, and now we come and replace it. So we come here. We come here. What do we do? Etap on pause, y is equals to x minus 1, which is equivalent to x is equals to x plus 1. So we've made x a subject to the formula and we've paused x to the racine. So if y is equals to x minus 1, on our equation here, where there's x minus 1, we're going to put y because we've equated this to be equals to y. So this is where we say this is equals to our y4, where we are our y to the power 4. And then here where there's x, we said x is equals to y plus 1. So we're going to say y plus 1 where there's x, because here it was x squared. So y plus 1 squared plus 1. Then here we use our normal form, which was x to the power 3, right? Before we simplified it, it was x to the power 3. So we get its actual form before we decomposed it. So it will be y plus 1 power 3 plus 1. And then we do the mathematics. We do this, we simplify this. It's going to give us this. We simplify what is inside. It's going to give us this. Mind you, we said, is this dividing this? Careful. We say this dividing this. What did we say here? We said what? We said on etap 2, we said R1, our R1 after we put our Y, which is this, divided our C1, which after we put our Y, not the YM, it's just this dividing this, which will give us, which is what we're going to do here. So we do on effectuel our étape 2, right? Our étape 2, on effectuel la division euclidienne de 10 par l'ordre 4 moins 1. So our order, we get it from this 4 minus order 1 here. This is order 4, order 1. So we subtract them so that we know where we're going to stop from. And we're doing it, we're decomposing of puissance croissant. So we've put it in Poisson's croissant. We're going to start with this. It will be increasing like this. Even here, it will be increasing like this. So we're going to divide this into this as it will be increasing like this. So this is where I said on effectual la division Euclidean de in Poisson's croissant. I put it in Poisson's croissant, which is this. So it is this par l'ordre. What would be the order? It will be 4 minus 1 over 3. Suivant les puissances. So we've got this also. We've put its puissance croissant. So we've got this dividing this of puissance croissant. So we're going to do our division. We're only going to stop when our order is equals to 3. Careful on this. When our order is equals to 3. So our coefficient, our quotient. So we'll do the division Euclidean until we reach here to the power 3. When we just reach here, then we end, because we mind you, we're finding for 4 variables. We're finding 4 reals. We're finding 4 reals. Lambda, alpha 4, alpha 3, alpha 2, alpha 1. There are 4. So you know that you start with a constant on a polynomial. So we've got 1, 2, 3, 4. That's why when we use our equation, we stop on 3 and we'll have 3 values. We'll have 4 values, which is this, and this. So after we've done our division Euclidean of Poisson's croissant, we're going to find our quotient here. Then from our quotient, we just get its coefficient. So we've got this, this. So we just come here. This is what we have here. So we just say our lambda 4 is equals to 1. The way we've put them, so the form is very important. So the way we put them, our lambda 4 is equals to 1. Our lambda 2 is equals to negative 1 over 2. Our lambda 2 is equals to negative 1 over 4. Our lambda 1 is equals to 5 over 8. Then you've used your partie principale. On that, donc, we put them. X plus 1, we found our beta was 1 over 24, plus 1 over x minus 4, minus 1 over 2. What we found, we put it here. We found these values. Minus 1 over 4 over x minus 1. This plus 5 over 8, x minus 1, plus ax plus b over this. So we have found all the values. So partie principale, these, we found them using the theorem de partie principale, which we've learned today. And we have seen the way we find it. The first step, first of all, you pause of what you'll be finding, the racine of what you'll be finding is partie principale, so that you come and replace it in this form. So it will be y is equals to x minus 1, which is equivalent to x is equals to y plus 1. We've put x subject of a formula so that we can come and replace where there's x here with this. We replace it here, we simplify. We replace it here, we simplify. We're going to have this here, and then here we're going to have this. And then we do a division Euclidean of this into this of Poisson's croissant. Then we go to étape 2 on effectual division Euclidean de this par l'ordre. Our order is coming from what? Where we're going to stop is 4 minus 1 here. This is order 1, this is order 4. What is it going to give us? 3. Suivant les puissances, this. So we've put it this is dividing this. Then we do our division Euclidean. When I found this here, when I divided this into this, and then it gave me this, I did the multiplication. When I just reach here, I find the remainder here. I just stop from there. I just get its, I arrange it, and then I just get its coefficients. These are what are going to represent our lambda 4, lambda 3, alpha 4, alpha 3, alpha 2, alpha 1. Yeah. On that, donc, this we've represented it. So we're just remaining with this A and B. For us to prove this is very simple now. You just say, first of all, if you want to Nankan, there's the formula that you can use. If you already have all these, just multiply x throughout. And when you multiply x throughout, what is happening is that when you multiply x throughout, you say your x is going to positive infinity. This is a formula, you have to know it by care. So when you multiply x throughout, you say our x is going to positive infinity. So when you put our x here, so we're going to have our x here, 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 so here to be x squared, and our x here. And then our f3, we know that our f3 was the thing which we had simplified. This is our x3. We also multiply our x here on top. So for you to use the one where we're saying x is going to positive infinity, this is the formula. Our limit here, if our Poissons here, they're not equal, this is equals to 0. If they are equal, it's equals to a coefficient of 1. So we are saying if we multiply our x here, our degree of the polynomial here to be 3, our degree of a polynomial here is equals to 7, which is this degree here is not equal to the degree on top. This is equals to 0. This is equals to what? To 0. This is what I said. Our f3 will be equals to 0. We equate it. We've put our x here. The degree here is same as the degree here, which is 1. So what we're going to have? We're going to have 1 over 24. 1 over 24. So our limit here will be 1 over 24. It will be 1, our limit. So we just get, it will be r. So we're just going to have our value here, which is 1 over 24. 1 over 24. Here it will be x. It will just be x degree 1x. This will be degree 4 when we distribute it. So this will be 0. This will be degree 3. It will not be equal. The degree on top and down, it will be 0. The degree here to not be equal to be 0. But the degree here to be equal because it will be x. So it will be degree 1, degree 1. So we get this 5 over 8. Then here to be x squared. Rx squared. It will be the same as the degree here. So our r here will remain. R will remain, and then here to be x1. It's not the same as the degree here because it's degree 2, this is degree 1. So this b will be 0 here. It will be 0, so just remain with our r. And then we can find our r, we just add these and then we take the other side. So our r is equals to negative 2 over 3. So found our r. And then if we've found our r, we can find our b. Our b, we just say x is equals to 0. We put our x to be equals to 0. So x is equals to 0, here we're going to have 1. 1 into this to be 1 over 24. Here when x is equal to 0, we're going to have to be negative 1 inside Poisson's cut. It will be 1, so it will be 1 into 1, it will still be 1. We'll put our 0 here. It will be negative 1. Negative 1 into negative 1 over 2, it will be, or positive 1 over 2. Here we're going to have 1 because it's even. So 1 into this is to negative 1 over 4. When you put here to be negative 1, so here to be negative 5 over 8. When you put our 0 here, this will be 0. Then here of 0, 0, have 1, 1 into b to be b. So we can add all these, we take them the other side, we find our b. Our b is equals to 1 over 3. So we found them. Our r, we're going to put them 1 over 24. For that one, this, we put these which you found there, and then we put the values which you found for and b. Negative 2 over 3x plus 1 over 3. Alors, on a décomposé dans R complètement. Yeah, we've decomposed in R complètement everything, and we found its values. This is all about decomposing. This is also the partie principale is very important because it will make your work very easy when you do it here. You found these, you've put your values, you just remain with your RB, you just remain with your RB, and then from here you can now say x is equals to positive infinity. And then you say if x is equals to positive infinity, you have to multiply x throughout here. That's the formula. Then if the degree on top is not equal to the degree down, just know it's equals to 0, it's equals to 0. If the degree is the same, you get what you have there. Yeah. You get, if you had r here, you get r, and the representation of r is 1 over 24. This is what we did. And then the other one, we just say x is equals to 0. So we put our 0 in f nank, and here we have 0. We have 0 plus 1, so it will be 1 here, and then here when you put 0 to be -1, which was 4, so it will be 1. Put 0 here to be 1, so 1 times 1 over 1. So that's why when we had put 0, we had 1 here on our equation. We had 1, we had 1 on the other side is equals to, and then you start putting on these others. When you put our 0, these are the values we'll be finding, and then you simplify it. Yeah, so that's why if you want to use this 0 and the one for positive infinity, you have to make sure that you found these other values. Because if you've not found them, you'll find that here you have lambda here, even here lambda 4, lambda a plus a. So you have to identify the lambda for you to find the a. So that's why first we got to find all these. Then you can use these, just use the multiply x f square. This means x goes to positive infinity. After that, you find the answer, knowing that here when x goes to positive infinity, it will be 0 when the degree is not the same up and down. When it's the same, you get what you have there. Yeah. Is it okay? Is it okay?
I've got a question.
Yes.
Like, how do you know that x is equals to positive infinity there?
X is equals to what?
Positive infinity.
X is equals to positive infinity. That's the formula. When you multiply x throughout, you say, here you're just finding the limit of it. You're finding the limit of it when x goes to positive infinity. It's going to give you 0 there. It's going to be 0. So it's just you are finding the limit. So always know that for you, when you found these others, this is the formula that you have to use. Now, if you found everything, you can use the formula of saying, let x goes to positive infinity. When you find x goes to positive infinity, let x go to what? 0 now. So after positive infinity, you go to 0, and then you start going. If they are still continue, you're going to say let x be equals to 1, let x be equals to -1. You put x equals to -1 throughout Shan, and then you see what you're going to find. So from here, since we've already found all these, we say, okay, for us to find this, you say you multiply x throughout. So when you multiply x throughout, you say your x goes to positive infinity. You're just finding the limit of it. But for you not to confuse yourself, this is where I am giving you a simpler form of saying, when you're saying x goes to positive infinity, know this, that when you multiply x throughout, if the degree on top is not equal to the degree down, just know that this limit will be equals to 0. If the degree on top is not equals to the degree down, the limit will be equals to 0. But if the degree on top is equals to the degree down, then just know the limit will be coefficient, the limit will be equals to 1. So if the limit is equals to 1, which means you're just going to get its non-can, the coefficient which is there. If it's equals to 1, you're just going to get its coefficient which is there. If it's equals to 1, you're just going to get the coefficient which is there. This is what we did. So on F2 there, the F2 which we have here there, the degree will not, the one on top will not be equal to the one down. That's why we've got 0 here. Then when we come to this, the degree here to be 1, even here the degree will be 1. That's why our limit will be equals to 1. So we've got 1 over 24. When you go to these others, it will be 0, 0, because here it will be 0, then here it will be 1, so it will be equal. This is where we've got, so our limit will be 1, which is equals to this. Here on x squared, the limit of this will be this is where I've put the limit of this will be 0. So this is where this goes. Yeah, are we okay? David?
Yes.
Okay. Any other question? Is it okay? Okay, so thank you very much. That's all about fraction Rationelle. You're not going to do more than this in fraction Rationelle. You're going to solve a lot of questions, but these principles, they matter. When you know complex numbers, the questions will come in complex. They'll tell you decompose in complex. Please just know these formulas which I've given you. When you go to your universities, you do more. I'll make sure this week I'll give you, we'll have a TD just prepare maybe 4 questions for a TD or 3 questions so that we see how we apply them. We see how much they applied. And then from there, we'll call it. And then I think we have an assignment also in fraction Rationelle. I will give you an assignment which you have to submit by that other week. When we do the TD, we'll do the assignment. I'll give you an assignment. Again, you'll be divided in the same groups so that as I'll be going, I should know that the guys this side, they have understood fraction Rationelle. Yeah, so thank you very much. We can call it a day. Thank you very much. I can now end the recording, and then I'll now go to questions.